Welcome to Exploring Creation with Physical Science, Experiment 12.2, Making and Using an Electroscope. The procedure is published in J. Wile's Exploring Creation with Physical Science, Apologia Educational Ministries. The purpose of this experiment is to make and use an electroscope to observe the process of charging by conduction and charging by induction. Equipment and materials used in this experiment are tape, a clear glass, I'm using a beaker, but a juice glass would work fine, a plastic lid that will fit over the glass. This is from a pre-prepared frosting container, and as you can see, that will fit over our glass there. A paper clip, 2 5cm by 1.5 cm strips of aluminum foil. The thinner the better. Get the cheap stuff. Don't get the heavy-duty aluminum foil. So in order to cut those strips, you're going to need some kind of measuring device, such as a ruler or a yardstick or meter stick, and a pair of scissors to do that. You'll also need a balloon and a pair of pliers. These are wire cutters, but they have plier end to them that will be useful to bend that paper clip. And then, of course, we need our eye protection. As always, before you do an experiment, you should have some place that makes sense to write your results. In this case, because the procedural steps are quite complicated, I recommend a table such as this one. So if you have not drawn up a table where you can enter your results that has these procedural steps outlined, then I highly recommend that you pause the video and go ahead and copy this down right now. So step 1 of the procedure tells us to use our hands and pliers to straighten out and then bend the paper clip end so it ends up looking something like it does in the book. So we've got our paper clip here, and getting the entire thing straightened out first, and then you can bend it into the loop. If you have pretty strong fingers, you can do most of this without the pliers. It's just the very end part when you're trying to bend these two ends up that those pliers are most useful. Like so. And then again on the other side. So then you end up with a shape like this. Step 2 tells us to cut a thin slot in the plastic lid. So that's where your scissors are going to come back in handy again. And right in the middle, we're just going to cut a thin slit right there. Not too long, about 1 inch or so. And then we're going to slide the loop of the twisted paper clip into that slot and then twist it 90 degrees so the slot holds the loop in place. So we are going to shove that through there. And then we're going to twist it so it's held in place. You may have to work with that a little bit, just like I'm doing here. And I've also found that if it won't stay for you, like this one seems to be having trouble, make sure that at the bottom, the 2 legs of the loop are not crisscrossing. Okay, so there we go. If you have to, you can use some tape to hold it into position. And if you need to do that, you can just put a piece of tape on either side of that loop. Like so. What you don't want is for that paper clip to be flopping around a whole lot and moving the bottom feet. You want those bottom hooked feet to be staying. Step 3 tells us to poke a hole near the one end of each strip of foil and hang the foil strips on the tiny hooks that are at the bottom of the twisted paper clip. So it's kind of like, you know, putting on maybe like you're hanging it on a hook. Okay. And I just use the end of the paper clip to poke the hole there. Okay, you want to make sure those are hanging down freely and not falling off like that. Okay, now it says to place the lid on top of the glass so the foil strips hang on the inside of the glass. Make sure you guys can see those. Okay. All right, step 5. Well, now that you've made the electroscope, what good is it? An electroscope detects the presence of electrical charge or electric charge. To see this, you're going to inflate the balloon and tie it off so it stays inflated. Go ahead and pause the video so you can inflate your balloon. Now in step 6, we're going to rub the balloon in our hair to charge it. Now this really does work much better in a dry climate. If you live in a very humid climate, make sure you have a dry day where it's not raining. Otherwise, it's going to be difficult to pick up the electrical charges from your hair. Remember, you're going to be picking up negatively charged electrons. Okay, step 7, we're going to slowly bring the balloon close to the loop of the twisted paper clip, but we're not actually going to touch it. Okay, and we're going to observe for those foil strips to move. So my balloon is close. Do you see those foil strips move? And it says, note how the foil strips move as you bring the balloon closer to the loop, but don't actually touch the loop with the balloon. Now step 9 says, pull the balloon away from the loop and note how the foil strips move. See how they go back together. Do this a couple of times so you can describe the motion of the foil strips well. When it goes towards the paperclip loop, they move apart. And when I bring the balloon away, it goes back together. So go ahead and record your results. That's actually going to be on the chart that I created, the first 2 steps. The balloon close to the paper clip, and then pulling the balloon away from the paper clip. So go ahead and write your observations there. And pause the video so you can do so. We're going to move on with step 10. Now bring the balloon near the loop one more time. This time, however, allow the balloon to touch the paper clip and note what happens to the foil strips. So the balloon has now touched it. Note what happens to the foil strips And now we're pulling the balloon away, and note what happens to the strips. Do you see a difference? So this time, that foil strip is staying repelled away from the other foil strip. It's not moving back down. Okay, so go ahead and record that result. You can pause the video here. And your chart should be looking something like this now. It's hard to get this all on without moving our electroscope here. So I'm going to have to move that slightly. So again, when the balloon was placed close to the paper clip, the foil strips moved apart. Then we pulled the balloon away. The foil strips then relaxed. Then when the balloon touched the paper clip loop, the foil strips moved apart, and then we pulled that balloon away, but instead of them relaxing, the foil strips actually stayed apart. Okay, let's move on with our procedure. You can see that those foil strips are still apart. Step 12 says, I want you to do one more thing. This might be a little tricky. Touch the loop with your finger, and you should notice that the foil strips respond to your touch. Note what they do. So eventually they start to relax. Now take your finger away from the loop. Let's go ahead and record that result. Had that as step 12, touch paper clip with finger. Foil strips relaxed. Go ahead and pause the video to write down your results. Okay, moving on with step 14. This is a little bit like patting your head and rubbing your stomach at the same time. So if you don't get this right the first time around, that's okay. But we're going to bring the balloon close to the loop, but not touch it. Now we've seen this before. You can see that the strips are moving apart slightly. I'm not seeing a whole lot of it here, so I'm going to rub the balloon some more on my head, on my hair. Get a good charge on there. Okay, so you can see that they move apart. Okay, now I'm going to leave the balloon there. Watch the strips carefully, and then I'm going to touch with my finger. They moved again. Then I'm going to take away my finger, and then take away the balloon. Okay, so we're going to put the balloon close to, but not touching the loop. And we see the strips move away from each other. Now I'm going to touch the loop. Again, make sure you've made your hypothesis before you do this, so you can make an educated prediction of what's going to happen. And those strips relaxed. Now I'm going to move my finger away, and the strips are moving away from each other again. And now I move my balloon away. And it's interesting, in the book in figure 12.3, it shows us exactly what we should be seeing. So I direct you to that figure there. But we've ended up now with both strips apart. So again, just to repeat that, I'm going to just discharge this and take away the charge. By the way, make sure you're not doing this with their feet at home. You're not going to get shocked or anything, but I find that it's easier to discharge the charge if you are wearing shoes or standing on a piece of hard plastic, for example. Okay, so again, the balloon, we're going to bring it near, the strips separate. We're going to touch with our finger, the strips relax. Then we're going to move away our finger, and then we're going to move away the balloon, and those strips are separated. Okay, pause the video to write down your results. Okay, so in step 14, those foil strips separated, but then they relaxed after touching. And then in steps 15 to 16, the foil strips stay separated. Now notice this is different. Before, when we touched the balloon or the paper clip with our finger, and then the foil strips relax, but this time now they are actually staying separated. And this is a difference between charging by conduction, where we're charging an object by allowing it to come in contact with it. Okay, so our first one, when we contacted the balloon with the paper clip loop, that was conduction. The negative charges from the balloon were transferred into this paper clip and down into the foil. So then we had negative to negative, which repelled, and that's why they separated apart. But in this very last part of the experiment, we were observing charging by induction, where we were charging an object without direct contact between the object and the charge. How did we do that? The balloon was brought close. It transferred its electrons to the foil strips. But then when we touched the paper clip that was attached to the foil strips, all those negative charges went through our body to the foil, got rid of all of those. And then more negative charges are coming from the balloon. And when we move those apart, those foil strips are actually staying separated now, not because they both are highly negatively charged, but they both actually have more positive charges on them. Why did they get those positive charges? Because we allowed all of those negative charges to come out through our body and leave those foil strips. Okay, that brings us to the end of experiment 12.2. I hope you've enjoyed it. I've enjoyed having you in the lab, and I will see you next time.